Welcome to This Explainer. Today, we're diving straight into something that sounds, frankly, like pure science fiction, but it's rapidly becoming reality. We are talking about devices that can literally heal themselves. We're going to look at a massive milestone in materials science today, specifically a newly granted Apple patent that is a total breakthrough for future foldable smartphone durability.
Okay, let's just address the elephant in the room, this universal pain point we've all faced. You know that agonizing, slow-motion feeling of dread when your phone slips out of your hand and just, smacks the pavement? Yeah, it's heartbreak. It's cost us all dearly, it makes us terrified of just using our devices naturally, and it's basically single-handedly propping up a massive global screen repair industry.
And the scale of this issue is absolutely massive. Get this, market research shows that nearly a quarter, 24% of all smartphone users have had to completely replace their screens because of severe damage. Up until now, our only real defense has been slapping on bulky cases or expensive screen protectors. But to really grasp why the tech industry is fundamentally changing its approach here, we need to first understand why current screens break in the first place.
Which brings us to Section 1, the fragile foldable problem. So, why are current bendable screens struggling so much? And why won't traditional protective glass cut it anymore? Well, for years, we've relied on chemically strengthened glass, like Gorilla Glass, which fights off damage by staying in this constant state of surface compression. But here's the catch. Static glass can't fold. When you switch to flexible polymer screens, like the polyamide used in today's foldables, you're introducing a whole new set of vulnerabilities. Think about it. Repeated folding creates immense mechanical stress. You've got tensile stress pulling on the outside and compressive stress squishing the inside. Over thousands of bends, this causes visible creases, material fatigue, delamination, and it makes the screen incredibly susceptible to scratches and dents from just everyday things like tossing your keys in your pocket.
But that brings us to Section 2, Apple's self-healing breakthrough.
Because on May 21st, 2024, the whole landscape of device durability shifted in a massive way. Now, there have been rumors for years that Apple was holding back on releasing a foldable iPhone until they could nail down these exact durability issues. Well, a huge piece of that puzzle officially locked into place when they were granted U.S. Patent 11991901. This isn't just some vague blue sky concept either. It lays out a highly detailed, literal roadmap for a foldable display cover layer that actively repairs its own scratches and dents. And the best part? You don't have to do a single thing. It completely shifts the paradigm from passive protection to active recovery.
So let's meet the real hero of our story, hidden within this Apple patent. It's a highly specialized, stretchable material layer. You see, instead of trying to force a rigid material to bend, Apple's engineers took a completely different route. They decided to incorporate a material that is literally designed to deform and then recover. We're talking about an elastomer. Now, if you're wondering what that means, just think of the memory foam in your mattress. When you press your hand into memory foam, it leaves a deep indent, right? But if you give it a moment, it just springs right back to a flawless, smooth surface. Apple is taking that exact viscoelastic property and applying it to the microscopic layers of a display. This allows the screen to absorb all that daily damage and then naturally flow right back into its pristine original shape. It's pretty mind-blowing.
So, how does this all come together? Let's jump to Section 3, how the magic works.
The architecture required to make this work without, completely ruining the optical clarity of your screen is absolutely fascinating. Imagine the display spanning a central bend axis. On the outer and non-folding parts, you have rigid displays made of standard glass or sapphire to give it structural support. But in the middle, right where the bend happens, that flexible hinge gap is thinned out and packed with our self-healing elastomer layer. And then, to top it off, bonded with optically clear adhesives, there's a layer of transparent conductors sitting right alongside that self-healing polymer.
Now, this setup means the screen can actually fix itself in two totally distinct ways. First, you've got autonomous healing. Thanks to those viscoelastic properties we just talked about, the elastomer can naturally flow and fill in surface dents all on its own at room temperature. It's a bit slow, but it works. But of course, Apple didn't just stop there. They also built in stimulated healing. This is where those transparent conductors come into play, allowing the device to seriously accelerate the repair process using external triggers.
By using transparent conductors like indium tin oxide, the device's circuitry can actually run a mild electric current right through the screen to generate localized heat. This heat lowers the viscosity of the polymer, putting the healing process into overdrive. So what does this actually mean for you? Well, it means your future foldable iPhone could automatically activate a heating layer while you have it plugged in at night, literally ironing out the day's wear, tear, and hinge creases while you sleep. You would wake up to a practically brand new screen every single morning. How cool is that?
But Apple isn't alone in this. Let's look at Section 4, the broader tech race.
Because, make no mistake, there is a massive industry-wide race happening right now to build the ultimate durable screen, and totally different battle plans are being drawn up. As we've seen, Apple is going all in on elastomers triggered by heat and light. But then you have Samsung relying on these defensive sensing loops, and South Korean researchers at KIST experimenting with something entirely unexpected and organic.
Let's look at Samsung's approach first, which acts a lot more like a digital immune system rather than a memory foam mattress. They've patented a system that embeds these ultra-thin, microscopic wires around really delicate areas, like the camera cutout. The exact second these wires detect a microscopic stress point, they activate what they call dummy metal patterns. These patterns instantly rush to reinforce the weak spot, stopping a microcrack dead in its tracks before it ever becomes visible to the human eye. It's a highly defensive strategy.
Meanwhile, you have researchers at the Korea Institute of Science and Technology, or KIST, who have developed a self-repairing, colorless polyamide, and their secret weapon? Linseed oil. Yeah, literally the exact same natural extract that's been used for centuries to preserve ancient oil paintings. They actually embed microscopic capsules of this linseed oil right into the screen. When the screen cracks, the capsules burst. The oil flows into the cracks, and then it hardens. When exposed to UV light, this process can repair 95% of a screen's damage in just 20 minutes. It is an absolutely stunning marriage of ancient natural materials and cutting-edge nanotechnology.
Okay, let's bring it all home in Section 5, the future of durability.
There is just a staggering amount of money on the line here. The global foldable display market is projected to surge from $6.1 billion in 2025 to a massive $13.29 billion by 2030. But, and this is crucial, that massive annual growth is directly dependent on solving these exact durability issues. I mean, let's be real, consumers simply won't adopt foldables en masse if the screens are just going to break after a year of normal use. Apple's patent is really a key to unlocking this multi-billion-dollar future.
And this self-healing breakthrough, it definitely won't stop at your phone. We're looking at a full-blown materials revolution. If Apple perfects this elastomer layer, you can absolutely expect to see it scale up to foldable iPads and MacBooks. It could even lead to Apple Watches with curved screens that just effortlessly brush off those annoying impacts against door frames. And looking way beyond consumer tech, materials like KISS self-healing polyamide are already being eyed by the aerospace industry to protect aircraft components. Even the green energy sector wants in, hoping to create incredibly resilient solar panels that maintain perfect transparency even after taking an absolute beating from the elements.
Which leaves us with this final, really provocative thought. We are entering an era where our technology possesses an almost biological ability to heal itself. Once cracked screens and scratched devices become a thing of the past, how will that fundamentally change the way we value, buy, and hold on to our technology? Will the lifespan of our phones double? And what happens to the massive ecosystem of repair shops when our gadgets just no longer need fixing? It's a fascinating future, and one that's unfolding right now. Thanks for joining me on this explainer. And definitely keep your eyes peeled for the self-healing revolution.